All right, today we're going to break down some of the invisible tech that keeps people safe in, well, some of the most dangerous jobs you can imagine. We're talking about a system built to do one simple but absolutely critical thing: deliver a clean, safe breath of air.
So let's kick things off with a little bit of a riddle. You've got these three jobs. They seem totally different, right? But believe it or not, they share one huge and potentially deadly common thread.
And that common thread is the air itself. Seriously, whether it's choked with paint particles, abrasive dust, welding fumes, or you just have no idea what's in the air of a confined space, the simple act of breathing becomes the biggest danger you're facing.
So, that's the big problem, right? If you can't just filter the air around you, what do? Well, the answer is you have to bypass it entirely. You bring a safe, clean bubble of air directly to the person who needs it.
And that leads us right to the heart of this whole system. Let's talk about the lifeline that actually makes this possible.
The easiest way to think about this is like a personal, portable, clean room, but just for your lungs. Instead of trying to clean up the contaminated air around you, it delivers pure, breathable air from a totally separate source, usually through a really long hose. It's kind of like having your own private atmosphere.
Okay, so if this system is a lifeline, what's it actually made of? Let's break down the different parts that have to work together perfectly to get that safe breath of air to the worker.
You can think of it like a chain with 4 essential links. You've got the source, the filters, the distribution, and the respirator itself. Each one is absolutely critical, and if just one of them fails, the whole lifeline is broken.
It all starts, you guessed it, at the source. This could be a special kind of compressor or just big bottles of certified clean air. But here's the crucial detail. If you're using a compressor, the air intake has to be located somewhere with clean air. You definitely don't want to be accidentally pumping car exhaust or other nasty stuff right to the worker.
Now, which source you use has a huge impact on the next step, filtration. See, if you're using a common oil-lubricated compressor, there's a real risk the motor could produce deadly carbon monoxide gas. Because of that, OSHA requires not just the standard filters, but also a dedicated carbon monoxide monitor with an alarm that's loud enough for the worker to hear no matter what they're doing.
All right, next up, getting the air to the person. To make sure the worker gets enough air at the right pressure, that hose can't just be any length. OSHA has a hard and fast rule: 300 feet maximum. You go any longer than that and you risk a dangerous drop in airflow.
And this is actually a brilliant little piece of safety engineering. The fittings that connect the breathing hose are made to be different from the ones used for, say, power tools. This makes it physically impossible to accidentally plug your mask into a line with non-breathable shop air, which you can imagine would be a fatal mistake.
And finally, we get to the part the worker actually wears. Now, choosing between a tight mask that seals to your face or a loose hood that flows air over your head, well, that's not just about comfort. It actually changes the whole design of the system. Those loose-fitting hoods need way more air volume to keep the bad stuff out, and that affects everything, all the way back to the compressor.
So look, you can have the best compressor, the best filters, the best hoses, but it's all completely useless if the air inside it isn't pure. And this brings us to the air quality standard itself.
And this is where the rules get super specific. You can't just pump what you think is fresh air down the line. OSHA has a very strict standard for breathable compressed air, and it's known as Grade D air.
This table basically gives you the exact recipe for Grade D air. The oxygen level has to be right in that sweet spot, almost the same as the air we're breathing right now. But then, you've got these incredibly strict limits on contaminants like carbon monoxide, CO2, and even oil vapor.
And the one to really pay attention to here is the carbon monoxide. Just 10 parts per million, max. To give you an idea of how small that is, that's like finding 10 specific people in a city of 1 million. It is an incredibly low limit for a gas that you can't see, you can't smell, and is absolutely lethal.
Okay, so we've got the hardware figured out, and we have the standard for the air. But even the most perfectly built system in the world can fail if the people using it aren't ready. The human element is every bit as critical as the technology.
And because of that, OSHA requires a whole written program. This means before a worker can even put on a mask, they have to be medically cleared for it. Then, they have to get trained every single year on how to use it, what its limits are, and what to do if something goes wrong. And if they're using one of those tight-fitting masks, it has to be professionally fit-tested to make sure it creates a perfect life-saving seal on their face.
And one last thing, we have to remember, This is life support equipment. And just like any life support equipment, it has to be obsessively maintained so you know it's going to work when it matters most.
You absolutely cannot just set this system up and forget about it. Companies are required to have a preventative maintenance plan, and this is especially true for those super important carbon monoxide monitors we talked about. Their sensors have to be checked and calibrated all the time. And get this shows you how serious it is. This isn't just a quick visual check. We're talking about a monthly, hands-on test using a special canister of certified CO gas to prove that the sensor and the alarm are working perfectly. That constant vigilance isn't just a good idea, it's a core part of keeping people safe. So when you put it all together, the big takeaway here is that a grade D breathing air system is so much more than just a mask and a hose. It's really a complete ecosystem. It's technology, strict standards, and rigorous human procedures, all working together for one single purpose: to deliver a safe breath of air where one doesn't exist. It's a pretty powerful reminder of all the complex engineering that works behind the scenes, totally unseen, to keep us safe. And it really makes you wonder, doesn't it? What other invisible safety systems are all around us, protecting us every day in ways we don't even notice?